f and g are defined as follows. So these are your function, and these are the question based on the function here. This question were taken from the June 2022 past paper, question 4, part A. So again, please attempt the question before looking at the solution. All right, so question 1, we are given the function gx equal 3x minus 1, and we ask to find g 1/3. So again, the function g is 3x minus 1. G of x means to say x will be the input into the function g, and we specify the input to function g. So 1/3 indicates the input to function g. So anywhere we see x in the function g, we're going to replace it with 1/3. So g 1/3 equal 3 multiplied by 1/3 minus 1. When we work out 3 multiplied by 1/3, that gives us 1 minus 1, which is equal to 1 minus 1 equals 0, and that's the answer there. Now, how did we get 1 as the answer here? We could go to the working column here. 3 over 1 multiplied by 1/3 equal numerator by numerator, 3 by 3 and 1 by 3. 3 by 1 and 1 by 3 give us 3, which gives us 1 as the answer here, because numerator by numerator, denominator by denominator. Looking at our second question, we asked to find the inverse of function f, where the input to the inverse function is -3. So again, this is a two-part question. So a two-part question in which first you have to find the inverse of the function. After having found the inverse of the function, you need to find the value of the inverse function when the input to the function is -3. So our first goal here is to convert this to an inverse function. So as usual, we'll replace this part of the equation with y. So y equal 5x plus 7. After having done that, we're going to interchange x and y. Now, again, it's my practice to flip the equation, so I get y on the left-hand side. Again, when I flip the equation like this, nothing changed, right? The equation remains exactly the same, nothing changes. The benefit of this is that we will have our y, or our subject of the formula, on the left-hand side. So now I need to get rid of the 7 and the 5 here. So it'll be 5y. So to get rid of the 7, I minus 7 on both, 7 on this side, and also do the same on the other side here. That will leave me with 5x equal x minus 7. Now I need to get rid of the 5. I divide out the 5 on both sides. Each term on the other side is divided by 5. So I have y equal x minus 7 all over 5. And again, if I have a common denominator, to fraction with the common denominator, I'll just express my numerator over a common denominator, 5 in this case. Indicate that this is my inverse function. So my inverse function f inverse x equals x minus 7 all over 5. And this is my inverse function. Now, after having worked out my inverse function, I need now to find the second part. So in the second part now, we want to find the value of the function when the input to the function is -3. So again, this indicates the input to the function. So anyway, I see x, I'm going to replace it by -3. So it's -3 minus 7 all over 5. -3 minus 7 will be -10. Negative 10 divided by 5 will give me -2. And that's the answer for this question here. So I'll restate my answer. So the answer is f inverse -3 equals -2. And that's the final answer. So again, it's a two-part question where first I find the inverse of the function. I went ahead here and found the inverse of the function. After having found the inverse of the function, the second part is where I input -3 into the inverse function and I work out that, and I arrive at my answer as -2. Right, so looking at question 2. This question was taken from the June 2023 past paper, question number 4. So again, before looking at the solution, answer the question. So you'll get pen and paper and answer the question before looking at the solution. Right, so part A, number 1, for what value of x is a function fx undefined? A function is undefined if its denominator is equal to 0. Right, so whenever the denominator in the function is equal to 0, the function is undefined. Now, to make this function undefined, the denominator must be equal to 0. So in order to find out what is x, what is the value of x when the function is undefined, we need to take the denominator x plus 2, set it equal to 0, and solve for x. So in this case, x equal -2. So therefore, for the function to be undefined, the x value has to be -2. We could look at it here. So it's 3 when x is -2 plus 2. We have a situation like 3 over 0. So in this case here, the function is undefined because the denominator is 0. So to recap, looking at the second question, find the value of g a quarter. So the function g equal 4x minus 5. To find the value of g a quarter, remember quarter will be input to the function. So the input to the function g is a quarter. Anywhere we see x, we'll replace it with a quarter. So this is 4 multiplied by a quarter. 4 multiplied by a quarter, this will give us 1 minus 5. So 1 minus 5 is -4. So our answer g 1/4. So the function g, when the input to the function is a quarter, the answer is -4. To see how we get 4 over 1 multiplied by a quarter equal 4 by 1 is 4, 1 by 4 is 4. When we work out that, the answer is 1. So that's how we get the 1 here. So it's 1 minus 5 gives us the answer here. Looking at part A2b, find the value of h -3. So we want to find the value of the function h when the input to the value is -3. So anywhere we see x in the function, we'll replace it with a -3. So -3 squared will give us 9 plus 1, which is equal to 10. And that's the answer. Again, -3 multiplied by -3 equal 3 3s are 9. A minus multiplied by a minus give us a positive answer. So our answer is +9. Hence, our final answer is 10. Looking at the part C, A2 part C, find the value of f0. This question has to be done in 2 parts. First, we need to find f0, and having found the value of f0, we need to input that into. So we need to take the answer of f0 and input it into the function f to work out our final value. So first of all, we're going to find f0. So f0 equal 3 over x. Anywhere we see, remember this is the input to the function. So the input to function f will be 0. So it's 3, 0 plus 2, So it's 3 over 2. So that's f0 equal 3 over 2. Now, having done this, we need now to use this as the input to function f. So now we'll continue with the question. So f0 equal 3x plus 2. Now f0 works out to be 2/3. So we're going to replace f0 with 2/3. So f0 now becomes 2/3, or 3 over 2 equal 3x plus 2 plus 2. So it's 3 divided by 3 over 2 plus 2. Now to answer this question, we first of all, because this is a fraction, you have a numerator. So 3 is a numerator and this is your denominator. So now we need to simplify the denominator. So I could go to the column here, 3 over 2 plus 2 over 1. So 2 into 2, 1, 3 is 3 plus, how much 1 into 2, 2 is 4. So this equals to 7 over 2. So this denominator becomes 7 over 2. So after having simplified the denominator here, it became 7 over 2. So now we have 3. So we could restate this as 3 over 1 divided by 7 over 2. Right, so it's 3 over 1 divided, this part became 7 over 2. Remember, we don't divide, so we don't divide fraction. We're going to change it to a multiplication sign. So it's 3 over 1 multiplied by, and we invert, or we turn it upside down, 2 over 7. So after working out this here now is 3 by 2 is 6, 3 2s are 6, 1 7 is 7, 6 over 7. And that's the answer there. So again, I'm just going to recap. This question has to be done in two parts. First, we find first we find f0. f0 gives us 3 over 2. After having found f0, we inputted that into the function f again, because we are going to reuse the same function f. So we input 3 over 2 into function f. So anywhere you see an x, we inputted 3 over 2. And remember, this is a fraction here. So we simplified the denominator of the fraction, and we got 7 over 2. So it's 3, and 3 is the same as 3 over 1 divided by 7 over 2. We went ahead and do a little conversion here where we change the sign to multiplication and we invert the second equation. So we invert the second fraction and we arrive at our answer as 6 over 7, and that's the final answer there. Well, looking at part B, we are asked to write an expression in the simplest form for g each x. So what they're asking us basically is to work out a composite function where the function h becomes the input into the function g. So the function h is x squared plus 1. So we're going to replace h of hx with x squared plus 1. So now the input in the function g will be x squared plus 1. And we know that function g is 4x minus 5. So 4x minus 5. And the input to this function here is x squared plus 1. And when I say input, I mean to say that wherever I see x, I'm going to replace it with x squared plus 1. So this becomes 4x squared plus 1 minus 5. And we work out this here, this becomes 4x squared plus 4 minus 5. And when we simplify, because the axis is simplified fully, so this becomes 4x squared minus 1. And this is the answer. Well, look at the last question here. The asked us now to find G inverse negative 2. So again, it's a two-part question. So it's a two parts. First, we find the inverse of function G. And function G is, so this is function G, and we want to find the inverse of this function. So we're going to replace the gx with y. So this part of the function is replaced with y. So y equal 4x minus 5. Now we interchange x and y. Now having interchanged x and y, we want to make y the subject of the formula, but I'm going to flip the equation. So y will be on the left hand side when I finish. Now to make y the subject of the formula, I need to remove the negative 5 and the 4. So I'll start with this here. So this becomes 4y equal x plus 5, become plus 5 on both sides. So if I do the inverse of something, it will remove that from this side here, and I do the same on the other side of the equation. So it's x plus 5. Now I have 4, so I'm going to divide out the 4. Each term is divided by 4. So y equal x plus 5 all over 4. Because we have a common denominator here, we could express the numerator over a common denominator of 4. So now our inverse function G inverse equals x plus 5 over 4. And this is our inverse function. Now the second part, so that's part 1. The second part, we need to now input negative 2 into the inverse function. So our inverse function, G inverse x, now x is replaced by negative 2 equals x plus 5 all over 4. So now what we're going to do, because this is our input value, so the inverse function G, so the input value, wherever I see x in the inverse function, I'm going to replace it by negative 2. So now after having done that, my answer will be negative 2 plus 5 will give us 3 over 4. So the answer in this case is 3 over 4. So G inverse 2, so G inverse negative 2 equals 3 over 4. And you always indicate what the answer is. What they ask you, they ask us for G inverse 2. So you always show that in the last year. So again, I'll just recap. So find the value of G inverse negative 2. So I'm going to input negative 2 in the inverse function of G. But first I work out the inverse function of G. And the inverse function of G give me x plus 5 all over 4. Having worked out the inverse function, this is my first part of the question. I go on to the second part now, where I take the inverse function and I input to that function negative 2. After inputting negative 2 into the function, I worked it out, and it became 3/4. And this is my answer here. All right, so looking at this question here, taken from the June 2019 question 8, part A. So these are the questions based on the function question. So again, do the question before looking at the solution. Well, looking at this part of the question here, state the value of x that cannot be in the domain of the function f. Now the domain is your x value. So again, in this case here, the domain will be your x value, for instance, 1, 2, 3, 4. This is your domain. So your x value is the domain. Now, we do not want a function in which the denominator works out to be 0. If the denominator works out to be 0, then the function will be undefined. So the function will be undefined if the denominator equals 0. So we do not want x to be such that the denominator works out to be 0. Right, so this is what the question is asked. So we do not want x such that the denominator works out to be 0. Now they ask us to state the value of x that cannot be in the denominator. So we need to set this denominator, in this case here 2x plus 1, set it equal to 0 and solve for x. So 2x equal minus 1, x equal negative 1 all over 2. Right, because we divide out the 2 here, leaving x alone. Minus 1. So x cannot be negative a half. So we cannot have, as part of our domain, which is the x value, we cannot have x being a half. Because if x is a half, if x is negative a half, well, then the denominator will be 0. And if the denominator is 0, then the function will be undefined, and we don't want a situation like that. So again, let me just recap here. So if I were to plug in negative a half into the denominator, it will be 2 multiplied by negative a half plus 1. 2 by negative a half will give me negative 1 plus 1 equal 0. So negative 1 plus 1 gives me 0. Now the function f is 9 over 2x plus 1. And into this function here, we want to input function g. But what is function g? Function g is x minus 3. So to function f, to the function f, which is 9 over 2x plus 1, we want to input to that x minus 3 because function g is equal to x minus 3. So again, we'll restate the question here. Anywhere we see an x in function f, we're going to replace it with x minus 3. So this will become 2 multiplied by x minus 3 plus 1. This works out to 9 over 2x minus 6 plus 1. This gives us 9 over 2x minus 5. And that's our answer. So the answer to the question f g of x. So again, the answer to the question of g of x equal 9 over 2x minus 5. Looking at the second part of the question, we are asked to find f inverse x, which means that we want to find the inverse of function f. So the function f is so this is our function f, and this function we want to find the inverse of this function. So again, the usual practice is that we want to replace the f of x with y. So y equal 9 over 2x plus 1. Having done that, we want to interchange x and y. So after interchanging x and y, we want to make y the subject of the formula. Again, when we have a division line and an expression, an algebraic expression under the division line, as in this case here, you're going to put it in brackets. So now we have a situation where we have x equals x equal 9 all over 2y plus 1. We first of all need to get rid of the denominator. So I'm going to multiply out the denominator, and again you put a bracket under it because you're treating this as a singular unit. The 2y plus 1 is treated as a single number, so you have to manipulate that as a singular number. So we're going to multiply out 2y plus 1 on both sides. And we do the same on the other side. So it's x by 2y plus 1 equal 9. Now that we have 2xy plus x equal 9, we need to make y the subject of the formula. So what I'm going to do, I'm going to get rid of the x by minusing x on both sides. This leaves us with 2xy equal 9 minus x. Now that we have that, I'm going to divide out the 2x because each term on the other side is also divided by the 2x. So y equal 9 minus x over 2x. So when we have a common denominator in our fraction, we could express the numerator over a common denominator. And this is our inverse function. So our inverse function f, equal 9 minus x all over 2x. And this is our answer here. So first of all, this is a two-part question. We have to first work out G10. So G10 will be ten minus 3, which is equal to 7. So again, G10, this is a function. Anywhere we see x, we're going to replace it with 10. So 10 minus 3 equals 7. So this is the first part of our question. The second part of the question, remember when we have a statement like this, the second part becomes the input to the first function. So G10 becomes the input to function f inverse. And function f inverse we worked out previously. The function f inverse worked out to be 9 minus x over 2x. That was worked out in the previous question. So now we're going to input into function f inverse. Into the function f inverse, we're going to input G10. And since G10 is 7, the input to the inverse function will be 7. And we know that the inverse function is 9 minus x all over 2x. So wherever we see an x in the inverse function, we're going to replace it with 7. So this becomes 9 minus 7 over 2 by 7. So we could go across. So now we have 9 minus 7 equals 3. 9 minus 7 equals 2. So 9 minus 7 equals 2, and 2 by 7 is 14. So the answer is 2 over 14, and the answer is 1 over 7. And this is the final answer for this particular question. Again, I'm going to recap the question here. Asks us to find the value of f inverse G10. So we know that if we are given a statement like this, the second part of the statement becomes the input to the first function. So G10 becomes the input to function f inverse. So we do not know the value of G10, so we have to go and work out the value of G10. Across here, we worked out the value of G10. G10 equals 7. After having arrived at 7 for our answer, that will be the input to the inverse of function f. Right, because again, G10 is the input to function f inverse, and G10 works out to be 7. So anywhere we see x in the inverse function, we're going to replace it with 7. We did that, so it's 9 minus 7 to multiply by 7 gives us 2 over 14, which is equal to 1 over 7. And this is our final answer here. Okay, looking at the second question. Again, we're going to look at the second question, which was taken from the June 2021 question 4 part B. And again, do the question before looking at the solution. Right, so the first part of the question, So the first question, determine the value of f9. So we want to find out the value of this function when the input to the function. So the input to the function f is 9. So again, this is function f. Function f is 1/3 x plus 4. 1/3 x, if I go across here, 1/3 x is equal to 1/3 multiplied by x over 1. So it's 1 multiplied by x over 3 multiplied by 1, which will give me x over 3. So always convert it to this format here because it's easier to work like this. So now the function f equal x over 3 plus 4. Into this function, I'm going to input 9 because remember the second part of the statement will tell you what is the input to the first function. So 9 is the input to the function f. So I'm going to state that here. So 9 is the input to function f, and this is function f here. So anywhere I see an x, I'm going to put, or I'm going to replace it with the number 9. So 9/3 plus 4, we could simplify this. So 9 divided by 3 give me 3. So 3 plus 4 equals 7, and that's the answer here. So it's a basic, simple question to start off with. The second question, calculate the value of fg negative 3. So fg negative 3, again, this question is a two-part question because we want this. So this becomes the input into the function f. So before we could take this and have it as the input of the function f, we need to work out what is g3. So this is a function g of x equals 3x. So gx equals 3x x plus 1. So that is the function g. And in the function g, we're going to input negative 3. So the input into this function is negative 3. So anywhere we see x into the function, in the function, we're going to replace it with negative 3. So it's 3 multiplied by negative 3. So it's 9 divided by negative 2. 9 divided by negative 2 will give me 9/2. Remember, a negative divided by a negative will give me a positive answer. So this answer is eventually a positive answer. Because again, minus divided by minus means the same answer will be positive. So g negative 3 equal 9/2. Now to work out the second part of the question. So the second part of the question, fg negative 3, and since g negative 3, so fg negative 3, I'm going to put that inside here. And since g negative 3 works out to be 9/2, this becomes f 9/2 equal, and into the function f, and this is our function f here, x over 3 plus 4. So into the function f, I'm gonna input 9/2. So wherever I see an x, I'm gonna replace it with 9/2. So this becomes 9/2 over 9/2 all over 3. So now we have 9/2 becomes 9/2 divided by 3/1, because 3 is the same as 3/1 plus 4. So this fraction, I state it out like this, and then I go and work it out in the working column here. So 9/2, we don't divide fraction, we multiply. So we change the sign to multiplication, and we invert this second fraction. Yes, we put 1/3. So this becomes 9 by 1 is 9, 1 9 is 9, 3 2s are 6, 9/6. And this could be further reduced to 3/2, because this cancels out 2 and 3, so it's 3/2. So this part of the question becomes 3 all over 2 plus 4. Now to simplify this, 3/2 is the same as 1.5. So 1.5 plus 4 will give me 4 plus 1 is 5. It will give me 5.5. And that's the answer to this question. So I'm just going to briefly recap this question here. The question asks us to calculate the value of f g negative 3. And when we have a question like this, which is a composite function, so the composite function means to say that you take one function and input it into the next one. In this case, the function, you take in function g and input in function g into the function f. But first of all, we need to work out what is g negative 3. We went ahead here and work out g negative 3. We arrive at 9/2 as being the answer. So g negative 3 is 9/2, and that becomes the input to the function f. Input of the function f means to say wherever I see x in function f, I'm going to replace it with 9/2. I did that, and then we went ahead and we worked out the final answer until we get 5.5. And this is the final answer here. Looking at the last question, calculate the value of x for which gx equal 5/2. Now this is your function here. We want to know what is the x value when this works out to be 5/2. Since g of x equals, so we have 3x all over x plus 1 equal 5/2. So when you get a question like this, normally you have an x value and you're asked to find the output of the function. So they'll give you x input, you replace the x with that input and you work out the value. In this case, it's a reverse. They give you the output, but they want to know what is the x input to the function. So what x value went into this function to give us an output of 5. So what they are basically asking us to do is to work out the equation 3x all over x plus 1 equal 5/2. This is the function g, and this function g is equal to 5/2. We need to know what x value went in the function to give us 5/2. So basically, we need to solve the equation for x. So to solve this equation for x, again, once you have the division line here, make sure you put this part of the question, x plus 1, in bracket, and you treat it as a single unit or as a single number. So it will be 3x over x plus 1. As we multiply out x plus 1 on both sides. So this will cancel out here. Now we have 3x equal, I'll just restate this here, 5/2 multiplied by x plus 1. Again, treat this as a single unit all over 1. So I'm going to treat this, for instance, if this, I'm going to treat this like this is a number, like for instance, let's say this is a number 9. So it will be 5 multiplied by 9. 9 5 is 45, and 2 multiplied by 1. So because this is a singular unit, it will be 5 multiplied by x plus 1. So it's 5 multiplied by x plus 1 all over 1 2 is 2. Again, numerator by numerator. When you multiply numerator by numerator, denominator by denominator. So this works out to be 5x. 5x plus 5 all over 2. So now we have 3x equal 5x plus 5 all over 2. So I need to solve for x. So I'm going to multiply out 2 on both sides. Again, when you're doing a function question, you must be very proficient in answering equation. So both sides multiplied by 2, so it's 2 by 3x equal 5x plus 5. 2 3 that's give me 6x equal 5x plus 5. Now I need to make x the subject of the formula because I'm solving for x. So I'm going to minus 5x on both sides. So minusing 5x on both sides give me 6x minus 5x equals 5. Now that I have this 6x minus 5x, or 6x box minus 5x box will give me 1x equal 5, and therefore x equal 5. And that's your answer there. So the value of x for which the function g of x equal 5 over 2 is 5. Now I could go and see if this is actually, okay, so we could now go and check and see if our answer is correct. So the function g of x equal 3x all over x plus 1. Now when x is 5, so when x is 5, let's see what will be our output when x is 5, which means to say anyway I see x in the function, I'm going to replace it with 5. So I have 3 5s are 15, 5 plus 1 is 6. I could break down that 3 into 6 is to 3 into 15 is 5. So indeed, if x is 5, my output is 5 over 2. Therefore, the value of x, so the value of x for which the function is 5 over 2 will be 5. And that's the correct answer there. Okay, so this question 1, taken from the June, so this was taken from the June 2017 past paper question 4B. You're given the following function and are asked to answer the following question based on the function given. So the first question, find the value of f3 plus f negative 3. So the first question we're going to work out here, but before we work out this question, let's do a manipulation here. So 1/3 multiplied by x equal 1 by x is x and 1 by 3 is 3. So this is the same as x over 3 minus 2. Now that we have this here, it's easier to work with when it is in this format here. So now we could go and work out when f3. So again, f3 means to say when the input to the function f is 3. So where I see an x, I'm going to replace it with a 3. 3 divided by 3 gives us 1 minus 2. 1 minus 2 equal negative 1. Looking at the other part of the question, f negative 3. So where I see x in the function, again the function is x over 3 minus 2. So where I see x in the function, I'm going to replace it with negative 3 over 3 minus 2. 3 over 3 gives us 1, but in this case it will be negative 1 because minus divided by a positive gives us a negative answer. So minus 1 minus 2 gives us negative 3. Now the question asks us plus f negative 3 equal negative 1 plus negative 3. The 1 and a plus and a minus, back-to-back plus and minus sign, like in this case, it will give us a negative. So plus and a minus, back-to-back. So back-to-back plus and minus equal a minus. So it will be negative 1 minus negative 3. Or we could look at it like this. It is plus 1 multiplied by negative 3. So it's plus 1 multiplied by negative 3. 1, 3 is 3. A plus by a minus gives us a minus when we multiply. So the answer in this case will be negative 4. And that's your answer to the question f3 plus f negative 3. So looking at the second question, calculate the value of x for which the function f of x equals 5. So again, the function f of x equals 5. What they're asking us to do is to find what was the input into the function that resulted in 5 as the output. So what we are really being asked in this question is to work out the function where the output value is 5. So this is a function x over 3 minus 2. And we want to know what was the x value that went into the function which give us an output of 5 or an answer of 5. So basically what they're asking us here to do is to solve the equation for x. So x over 3 minus 2 equal 5. First of all, we'll get rid of the 2 by plussing 2. If I plus 2, the inverse of negative 2 is plus 2, and that will eliminate the 2. I do the same on the other side, because when you do an equation, what you do on one side, you do the same thing on the other side. So plus 2 on the other side here. So my answer now is x over 3 equal 5 plus 2 is 7. Now I need to get rid of the 3 to leave x by itself, so I'll multiply out the 3 on both sides. Multiply now the 3 will eliminate the 3 and leave an x by itself. I do the same on the other side. I'll multiply 7 by 3. So x equals 21. So the value of x, which give an output, so this is the output of the function here. So the value of x, which give an output of 5, is 21. You can check that f21 is the x value we inputted into the function. So we're going to check. So 21 over 3 minus 2. 21 over 3, 3 into 21 is 7 minus 2. 7 minus 2 is 5. So indeed, 21 was the x value that went into the function to give us an output of 5. So your answer again is 21, x equal 21. So in the third question, we asked to determine the inverse of the function. So determine the inverse of function f. So this is our function f here. So determine the inverse of this function. First, we want to replace f of x. So this part of the equation, we're going to replace with y. So y equal x over 3 minus 2. Having done that, we're going to interchange x and y. So after interchanging x and y, we want to make y the subject of the formula. So to make y the subject of the formula, what I'm going to do, I'm going to flip the equation where I put the right-hand side on the left-hand side and the left-hand side on the right-hand side. This will ensure that the subject of the formula is on the left-hand side when I finish, because normally your subject of the formula is on the left-hand side. So this will ensure that it's on my left-hand side. So having done that, I need to make y the subject of the formula. So I'll get rid of the 2 and the 3. So I'll start with the 2 first, which is positive 2. So I'll introduce this negative 2. So I'll introduce this inverse, which is positive 2. That will eliminate the 2. And I have to do the same on the other side. So now that leaves me with y over 3. So y over 3 equal x plus 2. Now I need to get rid of the 3. So I'll multiply out the 3. And I'll do the same on the other side of the equation. So this leaves me with y equal 3 multiplied by x plus 2. Remember, when I multiply something on one side, each term on the other side of the equation is also multiplied by the same. So it's 3 by x is 3x plus 3 2s are 6. So y equal 3x plus 6. Now I need to answer the question. The question is f inverse. So I now change y to f inverse. This was a process of finding the inverse function. So this is the process of finding the inverse function. And when I finish, I need to show that this is my inverse function. So my inverse function is 3x plus 6. And that's the answer there. Okay, so looking at the last part of this question, we are asked to find the value of the inverse function f when the input of the function is negative 2. Again, we work out the inverse function of f, which was 3x plus 6. Now, this question was not on the exam paper, right? This is a modified question. It was not on the exam paper, but generally, if they ask you to find the inverse of a function, they will go on with another question asking you to find the inverse of the function when the input is a certain value. In this case, negative 2. So we have the inverse function 3x plus 6, and into that function, we're going to input negative 2. So where I see x, I'm going to replace it with negative 2. So 3 multiplied by negative 2, 3 2s are 6. A plus minus give me a 6. 6 plus 6 will give me 0 as the answer. So the answer to this particular question, f inverse negative 2 is 0. And this concludes this question. Question 4, looking at question 2. This is taken from the June 2018 past paper, question 4A. Now the first part of the question asks us, what is the value of f1? Again, we were given the function f is such that x maps onto a half x minus 3. When you get it in this format, you'll replace it with the equation format. So you're gonna put this in an equation format. So it's f of x equal a half x minus 3. Now before we start, we could a half x is the same as 1 multiplied by x all over 2. So it's x over 2. So we could replace it with x over 2 minus 3. So the function now is x over 2 minus 3. Now into this function, we're going to input 1 into the function. So again, this will tell us the input to the function. So anywhere we see an x, we're going to replace it with a 1. So it's 1 over 2 minus 3. And 1 over 2 minus 3 will give us negative 2.5. It's a simple question requiring a basic manipulation of the function. Looking at the other question here, we have find the value of x for which f of x equals negative 2. So find the value of x for which f of x equals negative 2. In this situation, what they are telling us, we have the function, and the output of the function is negative 2. So basically what they're telling us is that x over 2 minus 3 equals negative 2. So x over 2 minus 3 equals negative 2, and we are asked to solve x. So we asked to solve for x when the output to the function is negative 2. So basically what they're asking us is to solve for an equation in which we have to find the value of x. So again, what we'll do is x over 2 minus 3 equal negative 2. We'll get rid of the negative 3 by plusing 3 on both sides. If I plus 3, inverse of negative 3 is positive 3, and that will eliminate the 3 on this side here, leaving us with only 2x over 2 equal minus 2 plus 3 is equal to 1. And that's my answer. Again, find the value of x for which the function f of x equal negative 2. In this case here, they are asking us what is the input to the function. What is the input to the function? That is, what is the x value that went into the function that gave us an output of negative 2. So when we get question like this, all we have to do is set the equation to equal, in this case, negative 2, and solve for x, and this will give us our answer here. Now looking at the third question, an order pair is expressed in the form of AB using answer to 1 and 2 list the order pair for the function fx. So again, the order pair, we first of all, we found what was the order pair of 1 and 2 when the input to the function was 1. When the input to the function was 1, we got 2.5. And we got, when the input to the function was 2, our output was negative 2. So again, when the input was 2, when the x value was 2, the output was negative 2. So all we need to do is calculate for the last one here. So going back to the function, x over 2 minus 3. So f of x equal x over 2 minus 3. Now when the input to this function is 3, remember this will indicate the input to the function. When the input to this function is 3, we're going to replace x with 3 and work out the answer. The 3 over 2 minus 3. The 3 over 2, which will give us 1.5 minus 3. So 1.5 minus 3 will give us Right, so this works out to negative 1.5. So the answer here is negative 1.5. Right, so to answer this particular question, we asked to list the ordered pair for the function. So the ordered pair, again, we were given the domain, which are the x values, which are 1, 2, and 3. We worked out the range of the first of for the corresponding y value when x is 1, the corresponding y value is 2.5. And again, the domain is the x value, the range is the y value. The second one, when the domain is 2, the range is -2. And when the domain is 3, the range is 1.5. So negative 1.5. We went and we worked out 3 because 3 was worked out before, so we have to go and work out 3. So when 3 is the input to the function, the output becomes 1.5. So 3 and 1.5 will become an ordered pair. So again, the ordered pair will be arranged in the form of x and y, where x will be the domain value and y will be the range value. You could also label it A and B as in this case here, but the point to remember is that it must be ordered in the form of x, y. So the first value in the bracket here must be x and the second value must be y. So this is our first value, this is our y value, this is our x value, and this is our y value. So this is why they say it is in an ordered fashion, because it is in the order of x and y. Again, x followed by y. So it is in the order of x followed by y. And we know that x is the domain value and y is the output or the range to the function. And this is the answer to this particular question here. So looking at question 4. So looking at question 4, explain why f of x cannot equal 5 for the function f of x. F of x equal x over 2 minus 3. So therefore, y cannot equal to 5. So we're going to set x over 2 minus 3 equal 5. So we're going to set it to equal 5 and we're going to solve for x. X over 2 minus 3 plus 3 on both sides. So x over 2 equal 8. Multiply out 2 on both sides. X equal 8 to the 16. So x equals 16. So explain why the function cannot yield an input of 5. So why the function cannot give an output of 5 for the function? The reason is because in order for us to obtain an output of 5, x, which is the input to the function, has to be 16. So in order to arrive at an output of 5, x has to be 16. So if I plug, which means to say, if I plug 16 into the function, I must get an output of 5. So 8 into 16, 8 minus 3 equal 5. So it is only if I plug 16 into the function, I will be able to get an output of 5. However, according to our data, our x value, the domain given here is 1, 2, and 3. So the domain are 1, 2, and 3. And the output of this domain were also given to is negative 2.5, negative 2, and negative 1.5. 16, however, was not in the domain. So therefore, 16 was not in the domain. So because 16 was not in the domain, we cannot have the function given a value of 5 because 16 was not in the domain. So therefore, 16 was not in the domain. Right, so according to our data, the 16 is not a member of the domain. Hence, the function f of x cannot result in 5 being an output because in order for 5 to be an output, 16 has to be in the domain, and the domain that we were given in the question, 16 was not part of the domain. And that is the answer or the explanation for this part of the question. Looking at question number 6, which is taken from the June 2007 past paper, question 9, part A. So you are given the following function and I ask you to do the following question. Again, please attempt the question before looking at the solution. Please remember to attempt all questions before looking at the video solution. And if you're interested, I do give maths lesson both online and physical classroom. You can contact me at 345-9374. I specialize in one-on-one tuition and small classes. So if our online class is not your thing, you can always check me and we can arrange. Right, so the first question. The first question asks us to calculate the value of g negative 2. So this is our function g, and into the function, so you want to know the value of this function when the input to the function is negative 2. So again, anywhere we see anywhere we see x in the function, we're going to replace it with a negative 2. So negative 2 by 2 is that gives us negative 4 plus 1 all over 5. That gives us negative 3 over 5. Our final answer to this question is negative 3 all over 5. Looking at our second question here, we asked to write an expression for g f of x. So the function g is this here, and the function f is x plus 4. So again, what we have basically been asked here is to find the function g when f of x is the input to the function g. So we're going to take the entire function f and input it into the function g. So enclose everything in bracket, which means to say the entire content of this bracket will go into function g. So function g, and since f of x equal x plus 4, we put x plus 4 inside this parenthesis here. And function g is 2x plus 1 all over 5. So now this function is going to be inputted in the function g, and since the function f of x equal x plus 4, it is this that we're going to input into the function g. Remember, we cannot input fx into the function g. We have to input what fx is into the function g. So again, anywhere we see an x in function g, we're going to replace it with x plus 4. So that will equal 2x plus 4 plus 1 all over 5. When we work out this bracket here, when we FOIL out the bracket, this becomes 2x plus 4 2s are 8 plus 1 all over 5. And our eventual answer is 2x plus 9 all over 5. So this answers the question. So again, to recap, g f of x means to say we can take the function f of x and input it into the function g. So we went ahead and did that because the function f of x equals x plus 4. So we replace f of x with x plus 4 because that is the meaning of f of x. F of x means x plus 4. And it is this we're going to input in the function g. Right, so this is function g, and into function g we're going to input x plus 4. We went ahead and did that in this case here. So where we see an x, we're going to replace it with x plus 4. After having done that, we FOIL out this bracket here. We got 2x plus 8 plus 1, and our final answer is 2x plus 9 all over 5. Again, please attempt the question before looking at the answer. Right, looking at this question here, we have find the inverse function g inverse 3. So this is a two-part question. So two parts. First, you need to find the inverse. So we need to first find the inverse function, and then we need to input 3 into the inverse function. So first find the inverse function, then we're going to input 3 into the inverse function and work out what is our solution. So again, given the function gx equal to x plus 1 all over 5, we're going to replace g of x. So this part of the equation, g of x, you're going to replace it with y. So y equal to x plus 1 all over 5. Having done that, we're going to interchange x and y. Again, this is a process of changing a function into an inverse function. So in place, interchanging x and y, we get 2y plus 1 all over 5. Having done that, the next step is to make y the subject of the formula. So as the subject of the formula is usually on the left-hand side of the equation, I'm going to just flip the equation where y will be on the left-hand side. Remember, I'm just flipping the equation, right? Everything remains the same. The equation is the same equation, nothing changes. After having done that, I need to make y the subject of the formula. So I need to get rid of this 5, the positive 1 and 2. So I'll start by getting rid of the denominator first by multiplying out 5 on both sides. That will get rid of the denominator. Now I have 2y. So 2y plus 1 equals 5x. Having done that, I get rid of the 1 by minusing 1 on both sides. That leaves me with 2y equal 5x minus 1. Now to get rid of the 2, I'm going to divide the 2, and each term on either side is divided by the 2. So y equals 5x minus 1 all over 2. So when we have the common denominator, we could express the numerator over a common denominator, in this case 2. Now having done that, I need to show that this is my inverse function. So I'll just replace the y with g inverse x. So my inverse function is indicated here, g inverse x equal 5x minus 1. So this is our inverse function. Now the second part of our function, the second part of our question here is actually to work out the value of the inverse function when the input to the inverse function is 3. So when the input to the function is 3. So I'm going to restate this expression here. Right, and this indicates my input to the function. So the input to the function, in this case again, is 3. So anywhere I see a 5, anywhere I see an x, I'm going to replace it with 3. So if I choose a 15 minus 1, so if I choose a 15 minus 1 all over 2, which is equal to 14 over 2, which is equal to 7. So the final answer, g inverse 3 equals 7. So just to recap the question here, the question, find the inverse function g inverse 3. So first of all, we change this part of the question. So this part of the equation here is always changed to y. So y equal to x plus 1 over 5. And again, this is a process of converting, or the process of changing a function into an inverse function. So y equal to x plus 1 all over 5. We interchange x and y, and then we made y the subject of the formula. So after interchanging x and y, we made y the subject of the formula. But remember, I normally will flip my equation where I put the subject of the formula, in this case y, on the left hand side and the x on the right hand side. So after working out the inverse function, I arrive at g inverse x equal 5x minus 1, and this is our inverse function. So a question like this has to be done in two parts. First, you need to find the inverse function, and the second, input the value that they gave you, in this case 3. You're going to input that into the inverse function and work out a final singular value for that inverse function when the input, again in this case, is 3. So that's the process of doing a question like this here. So again, please, before looking at the solution, attempt each question. It is only then that you can learn to actually do functions or anything in maths. Right, so we want to find the value of this function when the input to the function is 2. So f2 equal 2x minus 3, and this is a function f of x, and into this function we're going to place 2. So anywhere where we see an x in the function, we're going to replace it with 2. And it's 2, 4 minus 3. 4 minus 3 equal 1, and this is the answer to this particular question. So basically the first question is normally a simpler question for you to work out. Looking at question 2, we are asked to find f inverse 0. Again, it's a two-part question. So it's a two-part question. First, you need to find the inverse function of f. And having found the inverse function of f, we need to work out the function where the input value, work out the value of the function where the input to the function is 0. So let's go ahead. So now f of x equal 2x minus 3. Again, we're going to replace the f of x, or this part of the equation, we're going to replace it with y. Having done that, and again, this is a process of converting a function into an inverse function. Having done that, we're going to interchange x and y. After interchanging x and y, we want to make y the subject of the formula. But I'm going to flip the equation, so y will be on the left-hand side. Right, now I need to get rid of the negative 3 and the 2 in order to leave y by itself, because again, we're making y the subject of the formula here. So I'll plus the 3 on both sides. Remember, the inverse of something will cancel out that. And I'm going to divide out the 2. Each term is divided by 2. So y equal x plus 3 all over 2. So if you have a common denominator in our fraction, just express the numerator over a common denominator, in this case 2. And this is our inverse function. Indicate that this is our inverse function. So our inverse function is f inverse x equal x plus 3 all over 2. So this is our inverse function here. Remember, x represents the input to the function, right? So we haven't inputted anything into the function as yet. Now we'll answer the second part of the question. So the second part of the question, we want to find the inverse function when the input to the function is 0. So f inverse 0. Since the inverse function is x plus 3, and this here, which represents our x value, is 0. So anywhere we see an x in the function, or anywhere we see an x in the inverse function, we're going to replace it with 0. So therefore, the inverse function of f, where the input to the function is 0, give us an answer of 1.5. So our final answer for this question here is 1.5. And remember, just to recap, we did it in two parts. First, we need to find the inverse function of function f. We went and did that, and we arrived at the answer of x plus 3 over 2. Having done that, we now go ahead and do the second part, which is we take the inverse function, and to the inverse function, we inputted 0 to the function. So 0, which means it's anywhere we see an x, we replace it with 0, and we worked out that. And our final answer is 1.5. So looking at our third question, we actually find the inverse of f inverse f2. So we need to find the value. Previously we worked out the inverse of function f, and we got x plus 3 divided by 2, and we also worked out the value of f2. So the value of f2 was 1, and this was the inverse function of the function f. Now what they're asking us to do is to find the value of f inverse f2. So f inverse f2 means to say that we'll take this particular value here and input it in the inverse of function f. Since the function f is x plus 3 over 2, which is this function here, so function f is x plus 3 over 2, and into this function here, so into this function f, which is x plus 3 over 2, we're going to input into that 1, which means to say anywhere we see x in the inverse function f, we will replace it with a 1. So the x is replaced with 1 plus 3 all over 2 equaled 4 divided by 2, give us 2 as the answer. And this is our answer to this question. Again, I'll recap the question here. We are asked to find the value of f inverse f2. We previously worked out the inverse of function f, which was x plus 3 over 2. And we also worked out what is the value of f2, which was 1. Now, f inverse f2 means to say that we're going to take this function and input it into the inverse of function f. So enclose everything in bracket here. And since f2, which is this function, f2 equal 1, we're going to replace the f2 with 1. And having replaced it with 1, we're going to input this one into the inverse of function f. So 1 becomes the input to the inverse function f. And we know that the inverse function f is x plus 3 all over 2. So where we see an x, we'll replace it with a 1. 1 plus 3 is 2, and we worked out the answer to be 2. And one thing to note about this question is that this question didn't actually ask us to work out all of these here. We had previously worked on this in the previous question, and they are the input to this question 3. So in exam, you'll always come across something like that, right? In exam, you'll take a previous question, the answer to previous question will become the input to a succeeding question. So expect that in exams. Okay, looking at question 8. Question 8, we are given two functions, f and g, and these are the function here. So these are the function. This question was taken from the June 2008 question 7 part B. Again, it was taken from the T&T past paper only. Remember, in 2008, we had two separate papers. One paper was for the Caribbean and one paper was for Trinidad and Tobago only, because there was some discrepancy in the 2008 past paper. So again, you had one for the Caribbean and one for Trinidad only. So in that year, you had two separate past papers. So look out for that. All right, looking at the first question, we asked to calculate the value of f0. We are given the function f is such that x maps onto 5x minus 2. Again, you're going to change this function to the equation format. So fx equals 5x minus 2. And we're going to solve this particular equation when the input to the function is 0. Again, the value here will tell us what is the input into the function. Anywhere we see an x, we're going to replace it with 0. And in this case, -2 is our answer. So it's a simple question worth about one mark. Looking at the second question, calculate g, the function g when the input is 2. So you're going to calculate g2. Again, the function was given as g is such that x maps onto 4 over x plus 1. You're going to change it into the equation format where you have g of x equal x over x plus 1. And to the function g, so to the function g, we're going to input 2 into the function, because I remember 2 now replaces the x in the function. So 2 replaces x, and whatever we have in the bracket here, that will tell us the input into the function. So anyway, you see an x, we'll replace it with 2. So our final answer for this particular question is 4 over 3. Looking at our third question, we asked to calculate the inverse of function f. Again, f -1 on top. This is the inverse of function f. And function f is equal to 5x minus 2. This part of the equation, as we normally do, we'll replace this part of the equation with y. So y equals 5x minus 2. We're going to interchange x and y. After having done that, we want to make y the subject of the formula. But I'm going to just flip the equation where I put the y term on the left-hand side and the x on the right-hand side. Now, having done that, I need to make y the subject of the formula. So I need to remove the -2 and the 5. So I'm going to plus 2 on this side here. So the inverse of -2 is plus 2, and that will eliminate the 2 on this side here. I do the same on the other side. So that leaves me with 5y equal x plus 2. Going to divide out 5 on both sides. Each term is divided by 5. So now this is my inverse function, y equal x plus 2 all over 5. Remember, if you have a common denominator, we'll express the numerator over a common denominator. In this case, is 5. We indicate that this is our inverse function. So to indicate this is our inverse function, is f inverse x. So this is our inverse function, f inverse x equal x plus 2 all over 5. Looking at our fourth question here, we have f inverse 4. Now f inverse 4, we already worked out the inverse in the previous question of function f. So the inverse of function f is x plus 2 over 5. Now to this function here, we want to input 4 into the function. So now x is replaced by 4. So 4 is inputted into the function, and then we want to work out the value of that. So coming across, f inverse 4 means to say that 4 becomes the input into the inverse function f. So we'll have now 4 plus 2 all over 5. So 4 plus 2 will give us 6 over 5. And our answer is 1 and 1/5. Again, I'll just recap this. F inverse x, we worked out that previously in the previous question. So this was done in the previous question. Now we are asked to take the inverse function and work out its value when the input to the function is 4. So again, 4 becomes the input to the function, or 4 becomes the input to the inverse function f. And since this is the inverse function, we're going to input 4 into this function. Wherever we see an x, we're going to replace it with 4. So we did that, and then we work out the answer, and the answer became 1 and 1/5. And that's the correct answer. So we have question 5. Calculate the value of x if f g of x equal 1. Now f g of x is the same as f gx, where we put the entire function g of x into the function f. So the function g of x is 4 over x plus 1. So we're going to take this entire function here. So the entire function g of x, and we're going to use it as the input to function f. So now this is function f is 5x minus 2. So now we'll take the 5x minus 2, which is function f, into this function here. So into this function, we're going to input the value of 4 over x plus 1, because 4 over x plus 1 is the function g of x. And since g of x is the input to f, we're going to take this and input it into the function f. So anyway, where we see an x, we're going to replace it with this bracket item here. So it'll be 5 multiplied by the content of the bracket. So it's 5 multiplied by 4 over, and we could go to the working column and work out this part of the question here. So it's 5, the same as 5 over 1 multiplied by 4 over x plus 1. So numerator by numerator, 5 4 is 20. And 1 multiplied by anything will be itself, so the bottom here will be x plus 1. So this works out to be 20 all over x plus 1 minus 2. So again, before we find what is x, we need to work out this part of the question here, where f of g, so we need to work out f gx. And that is what we're doing here right now. So now, in order to work out this here, so we're going to simplify this fraction. So in order to simplify this fraction, first find the LCM of this, and this will be x plus 1. X plus 1 into x plus 1 is 1. 1 by 20 give us 20. X plus 1 divided by 1, anything divided by 1 will give us the same thing. So the answer here will be 2 multiplied by x plus 1. When we finish here, we'll get 20 minus 2x plus 2 all over x minus x plus 1. Having done that, when we FOIL out the brackets here, it will be 20 minus 2x minus 2 all over x plus 1. Now when we simplify this here, so in order to simplify this, we'll get 18 minus 2x all over x plus 1. So now this is our function here. So this here is our function f g of x. So now we could restate f g of x. So f g of x equals 18 minus 2x all over x plus 1. Right, so now that we have arrived at this part of the question here, so f g of x is 18 minus 2x all over x plus 1. Now what the question asks us to find out, calculate the value of x if f g of x equal 1. And since this is f g of x, so this here is f g of x. So f g of x is 18 minus 2x all over x plus 1. So when this function is equal to 1, what is the x value? So we need to work out the x value. So it basically comes down to an equation where you have to solve for x. So now we'll multiply both sides by x plus 1. So 1 multiplied by x plus 1. So we have 18 minus 2x equal x plus 1. Now we need to get x is on one side and everything on the other side. So I'm going to minus out the 18 on both sides. This gives me negative 2x equal x plus 1 minus 18. Now we need to collect all the x on one side, so I'll minus x on both sides here. So it'll be minus 2x minus x equal negative 17. Minus 2x minus 1x will give me negative 3x. Negative 3x equal negative 17. Could go across here now. So now we have negative 3 equal negative 17. I want to just get x by itself. It's negative 3. Negative 3x equal negative 17. Going to divide this by negative 3. So negative 3 cancels out, and the same on the other side here. So x equal negative 17 divided by negative 3. So x equals 5 and 2/3. And this is your answer here. So I'm just going to recap. I'm going to recap the question here. Calculate the value of x if fg of x equal 1. Normally, x is the input to the function, but in this case, we do not know the input to this function here, but we know the output. So the process is, first of all, work out this part of the equation, work out this part of the question here. And we went and worked out that where f and the input to the function f is 4 over x plus 1. Because we're taking the function g. So we're taking the function g, which is 4 over x plus 1, and inputting it in the function f. And again, this indicates the input to function f here. So this is function f. Function f is 5x minus 2. So into this function, we're going to input the bracket content here. So it's 5 multiplied by 4 over x plus 1 minus 2. We went ahead and we work out that here. We arrive at our answer f g of x equal 18 minus 2x all over x plus 1. So this is our function here, which is the same as here. Now when this function equal 1, what is x? So because the function is 18 minus 2x all over x plus 1 is equal to 1, we are basically given an equation here where we have to solve for x. So we went ahead and we solved for x, and we arrive at the answer where x equal 5 and 2/3. So x equal negative 17 divided by negative 3, and negative divided by a negative will give you a positive answer. So therefore our answer is positive 5 and 2/3. Right, so again, practice, practice, and practice, and that's the only way you'll get this particular topic. Okay, looking at looking at question 4, given the functions, we have to answer the following question here. This is taken from the June 2003 question 10 part B. So question 1. Question 1, we have to find the value of G7 So G7, which means to say when the input value is 7, so the input value which is represented by x is 7 in this case here. So again, anywhere we see x in the function, we'll replace it with 7. Right, now that we have replaced the x with 7, we can work out this, which is a simple fraction to work out. 2 times 14 all over 7 minus 4 is 3, and that will give us 17 over 3, which will give us a fraction of 5 and 2/3. Okay, so this is just a simpler fraction to work out, and again our input value into the function is 7 in this case here. Looking at the second question, we asked to find the value of x. So we have to find the value of x when the function g of x equals 6. Now looking at the function machine here, x represents the input value into the function. So let's say that this is our function here. X represents the input value into the function. If x is 7, as in the previous question, when x was 7, we inputted 7 in the function and we get an output. So we got an output of 17 over 3. However, in this case here, we do not have an input function. So we do not have an input into the function, but we are given the output. Because what they're saying is that g of x equals 7, which means to say that the function gives an output of 6. So we need to state the question, or we have to restate the question as 2x plus 3 all over x minus 4 equals 6, because they give us the output. And we need now to find out what was the input value that went into this function to give us the output value of 6. So basically what we are doing, we are solving an equation where we want to find the value of x. So you're going to state the function x minus 4 equals 6, because 6 is the output value, and now we need to solve the equation. So it's 2x plus 3 all over x minus 4. And once we have a division line like this, we put everything in bracket because it's a single unit. So you're going to treat the denominator and the numerator as a single unit. Now we need to remove the denominators and multiply each side of the equation by the denominator. So we're going to multiply the denominator x minus 4 equal 6. Also multiply by the denominator that we are getting rid of, the x minus 4. That will cancel out and that will cancel out that. So now we have 2x plus 3 equal, when we FOIL out this, we get 6x minus 24. Now that we have this here, we have 2x plus 3 equals 6x minus 24. We want to collect x's on one side and everything on the other side. So what I'm going to do, I'm going to minus the 3 from here. Minus 3 will get rid of the 3, and I do the same on the other side. This leaves me with 2x equals 6x minus 24, and 3 is minus 27. Right, now that I have this, I'm going to flip the equation where I put the bigger x on the left hand side and the smaller x on the right hand side. Okay, so now that I have a situation like this, I need to get rid of the 27 from this side, so plus 27 on both sides. That will eliminate the 27 from the side, leaving x alone. So now I have 6x equals 2x plus 27. Now continue the question above here. So 6x equals 2x plus 27. Now I need all x's on one side, so I'll minus 2x on this side, and I'll do the same on the other side. So 6x minus 2x equals 27. 6x box minus 2x box will give me 4x box equal 27. I need now to get x by itself, so I'm going to divide out the 4. So dividing 4 on both sides will give me x equals 27 divided by 4. So 27 divided by 4 will give me 6 3/4. And this is your answer. So I'm just going to recap what happened here. In this question, we asked to find the value of x. Right, we asked to find the value of x when g of x equals 6. So again, they give us the output to the function. The normal thing is to ask us to find the output and giving us the input. But in this case here, they give us the output, and we don't need to know what was the input that went into this function to give us the output of 6. So when you get this situation here, you set the function equal to the output, and then you work out the x value, or you work out the value for x from this particular function here, from this particular equation here. So we went through the process here of working out the equation, and we arrive at the final answer, which is x equals 6 3/4. So the value that went into the function to give us an output of 6 will be 6 3/4. So 6 3/4 is the x value that went into this function to give us the output of 6. If we were to input 6 3/4 where we have x and work out this, we will get an output, and we'll get an answer of 6. And this is our answer here. Looking at question 3. Looking at question 3, write an expression for h of gx. So this is a composite function. So it's a composite function where we take one function and place it into the other function. So given the situation here, we're going to take h of gx. So we will write it as h gx. So we're going to take this entire bracketed content and input it into the h function. Now g of x, what is g of x? G of x is 2x plus 3 over x minus 4. So now we'll replace, so we'll have a situation like this. So g of x is replaced with 2x plus 3 all over x minus 4. So now we have this function here, and we know the function h is 1 over x. Right, so the function h is 1 over x, and into this function we're going to input function g of x, and since function g of x is equal to 2x plus 3 all over x minus 4, we're going to replace the entire x there with this entire bracketed content. So our answer will be 1 over 2x plus 3 all over x minus 4. So 1 over 2x plus 3. So we have a fraction here, so we could restate this as 1 is the same as 1 over 1 divided, because this is a division line here. That's the division line. So 1 over 1 divided by 2x plus 3 all over x minus 4. So now we have this situation here, but remember, we do not divide fraction. So we actually have a fraction 1 divided by 2x plus 3 all over x minus 2. So it's a fraction. So 1 over 1, we change the sign to multiplication and we invert. So we turn the fraction upside down. So it will be x minus 4 over 2x plus 3. So it's 1 over that. Now we continue the question around. So continue the question, we have 1 over 1 multiplied by x minus 4 all over 2x plus 3. Now this again is 1 multiplied by x minus 4 in brackets. Remember, this is a single unit, so you put brackets around it. over 1 multiplied by 2x plus 3. So 1 multiplied by anything will give you back the same thing. So x minus 4. So 1 multiplied again by anything will give you back the same 2x plus 3. And this is your final answer here. So again, to recap, write an expression for h g of x, which is a composite function, which means to say we take one function and input it into another function. We have the setup here g of h of gx, and since the function g of x is equal to 2x plus 3 over x minus 4, it is this that we're going to input into the function h, and the function h is 1 over x. So anywhere we see x in function h, we'll replace it with the bracketed content here. So we went ahead and do it here. And this again is a fraction, which is 1 divided by 2x plus 3 over x minus 4. Again, we don't divide fraction, we change the sign to multiplication, and we invert the second fraction, which is in this case. So the second fraction is inverted or turned upside down. After having done that, remember we multiply numerator by numerator. So it's 1 multiplied by x minus 4, and we treat this as a singular unit. And denominator multiplied by denominator, so we treat this as a singular unit. So 1 multiplied by anything is itself, and we have the answer here. Now looking at the final answer. The final answer, write an expression for g inverse x. So we want to find the inverse of this function. To find the inverse of this function, again, the first thing we do is we change the g of x into y. So this part of the function, we're going to change it into y. So y equal to x plus 3 over x minus 4. Having done that, we're going to interchange x and y. So where we see an x, we will replace it with a y and vice versa. So now we have 2y plus 3. Y minus 4. Now that we have done that, as is my practice, I'm going to flip the equation where I put the left hand side on the right hand side and vice versa. Right, now that we have this, again, when we have a division line and we have an algebraic expression on top, put brackets around it to indicate that it's a singular unit. So it's a singular unit. So now we need to remove the denominator. So the first thing when you get a fraction in an equation, you want to remove the denominator. So I'm going to multiply the y minus 4, again the entire thing because it's a singular unit. And I'm going to do the same on the other side here. So now I have 2y plus 3 equal xy minus 4x. Now the goal here is to make y the subject of the formula. So I'm going to get all the y's on one side of the equation. But before I can do that, I'm going to get rid of the 3. So I'm going to minus 3 on both sides. Again, the inverse of something will remove that. So I'm going to minus 3 on this side also. So now I have 2y equals xy minus 4x minus 3. Now having done that, I want to collect all the y's on one side of the equation. So I have 2y. I'm going to minus So I'm going to minus xy on this side of the equation. So that will eliminate the xy. And I'm going to, when you do that on one side, you also do it on the other side of the equation. Right, so now that we have all the y's on one side, what is our next step here? Because we have y in two places. So because we have y in two places, what is required here is a factorization. So we're going to factorize this side of the equation where you pull out the y. and we have 2 minus x. So factorization will give us the ability to extract the y on the outside, and then we have this part of the question here. Right, now we'll have y by itself here. So because y is connected with the multiplication sign to this part of the question here, we're going to divide out 2 minus x on both sides of the equation. So y equals negative 4x minus 3 all over 2 minus x. And this is our inverse function here. We need to indicate that this is our inverse function, so we're going to replace the y with g inverse. So okay, so looking at question 5, given the function, and these are the function here, and these are the question related to this particular function. This question was taken from the June 2005 past paper, question 6, part A. So again, all of these questions are taken from past papers. So if you were to do all of the questions that I'm currently doing, you should be in good stead when it comes to function. Okay, so the question asks us to find the function g3 plus g negative 3. So we need to work out g negative 3 also. G negative 3, so anywhere in the function of g where we see again where we see x, will replace it with negative 3. Negative 3 squared is equal to negative 3 multiplied by negative 3. 3 3s are 9, and a negative by a negative is a positive answer. So it's a positive answer. Now we need to answer the question g3 plus 3 negative 3 equal 9 plus 9, which is equal to 18. And your final answer for this question is 18. So it's a simple question that with enough practice, it should be easy for you to handle. Now looking at the second question, we want to find the inverse of function f. Inverse of function f with the input of 6. Again, function f was given in this notation here. F is such that x maps onto a half x plus 5. Change it to the equation notation. And to write this as an equation, you just write f x in bracket equal. So you change this to equal a half x plus 5. Now first of all, we're going to find the inverse function of f. So we're going to replace this part of the equation. So replacing this fx with y. So y equal a half x plus 5. A half x is the same as x over 2 plus 5. So y equal x over 2 plus 5. Again, we'll interchange x and y. So next step is to interchange x and y. Now having done that, we want to make y the subject of the formula. So to make it easy, I'm just going to flip the equation where y will be on the left hand side and x will be on the right hand side. So the reason for this is because we normally have y as the subject of the formula is on the left hand side, so it's already on this side, so it will be easier to work out. Now we're going to get rid of the positive 5, so we're going to minus 5 on this side, and we do the same on the other side. We are left with y over 2 equal x minus 5. Having done that, we need to get rid of this 2, so we'll do a multiply out 2 on both sides. So it's y equal, and again, each term on the right hand side of the equation is multiplied by 2 also. Right, so in fraction, when we multiply something on one side, every term on the other side is also multiplied by that item. So it's 2x minus 10. So y equal 2x minus 10, and this is our inverse function here. So we're going to indicate that this is our inverse function. So our inverse function, so the inverse of x, inverse of function f is equal to 2x minus 10. So we're going to replace the y with f inverse x equal to x minus 10. So this is the inverse function. Our final step now, because the question asks us, so the question asks us, they want to work out the inverse function with 6 as the input value. So now we're going to restate our function. So now our input value to the function is 6. So anywhere we see x in the inverse function, as in this case here, we'll replace it with a 6. So after we work out the f inverse 6, with 6 being the input into the inverse function, we get 2 as the answer. So I'll just briefly recap what we did here. First of all, we changed the notation from this notation to the equation notation. Then we replace f of x with y. So we replace f of x with y. Then we interchange x and y. After interchanging x and y, we made y the subject of the formula. And after having done that, we work out and we arrive at our inverse function as being 2x minus 10. We will state what is the inverse function and indicate that this is our inverse function. Then we, to the inverse function, the input to the inverse function will be 6. So you input that into the inverse function and we work out the answer, and our final answer is 2. Right, so looking at the third question here, find the value of f g2. This is a composite function where g2, the function g, is inputted in the function f. So now the function f is f of x, and this here will show us what goes into the function f. Right, so this part of the question will tell us what goes into the function f. However, because it's a composite function, we're going to replace this entire function in brackets here, and the content of this will be inputted into the function f. So this here will be the input into function f. However, before we can input this into the function f, we need to solve for function g when the input value to function g is 2. So first of all, we need to go to the function g. Since the function g of x equal x squared, and in this case our x value is 2. So anywhere we see an x, we'll replace it with 2. So it's 2 squared. 2 squared is the same as 2 multiplied by 2, which is 2 by 2 is 4. So g2 equals 4. Now, having worked out g2 and we having gotten 4 as the answer, we need now to go back at the original question here. So now we have f. So now we have f g2, and since g2 equals 4, right, so g2 equals 4, we're going to replace g2 with 4. So it's become f4. Okay, I hope you all following. So g2 now becomes 4 because we worked out that as being 4. So now we're going to replace the g2 with the actual number 4, and then this will be the input to the function f. Equal, we go back to the function f, and the function f is a half, or it could be written as x over 2 plus 5. Now into this function, into the function f, which is this function here, we're going to input 4 into the function. So anywhere we see an x, we're going to replace it with a 4. So it's 4 over 2 plus 5. 4 over 2, 2 into 4 is 2 plus 5 equal 7. And this here is our answer. So I'm just going to restate the final answer will be fg2 equals 7, and that's our final answer there. So this will conclude question 5. Again, please note that before you look at the solution to the question, work it out before you look at the solution to the question, right? Because that's the only way you'll actually learn to do something is by actually doing it. Looking at a worded question, given the following function, we are asked to answer the following question here. These questions are taken from the June 2002 past paper question number 6. Although it is a question from way back, they are pertinent to your exam even now. Please remember to attempt all questions before looking at the video solution. And if you're interested, I do give maths lesson both online and physical classroom. You can contact me at 345-9374. I specialize in one-on-one tuition and small classes. So if our online class is not your thing, you can always check me and we can arrange. So looking at question 1, we are asked to find the value of g negative 3. Now we were given the function as g is such that x maps onto 2x minus 1. So what we're going to do, we're going to convert it to the equation form. So from this notation, we're going to put it in the equation notation, and we're going to work with it like that. So when x is equal to negative 3, find the value of this function when the input value is negative 3. So again, anyway, I see an x, I'm going to replace it with a negative 2, negative 3. 3 to the 6, that's negative 6 minus 1. This will give us negative 6 minus 1 will give us negative 7. And that's our answer there. Okay, now that we are on to part B, question 1. So part B, question 1 asks us to determine the inverse of function f. So this is function f here. Function f written in equation format will be fx equal x over 2, x over 3 plus 1. So if you get in this format, you're going to write it in the equation format as it's easier to work with it in this format here. So the first step is to convert this into inverse function. Change the f of x into y equal x over 3 plus 1. After having done that, we're going to interchange x and y. After interchanging x and y, we want to make y the subject of the formula. However, as is my usual practice, I'm going to flip the equation where I put y over 3 plus 1 equal x. I put a y on the left hand side. Now I'm going to make y the subject of the formula, so I'm going to remove the 1 by introducing a negative 1. I do the same on both sides of the equation. This will eliminate, and I have y equal 3 x minus 1. I need to get rid of the 3, so I'll multiply out the 3 on both sides. So y equal, and again, if I'm multiplying the 3 on both sides, each term, so in solving equation, when you multiply something on one side, each term in the equation must be multiplied by the same item. So both x and negative 1 is multiplied by 3. So now y equal 3x minus 3. And this is our inverse function here. So our inverse function, we can now go across here and indicate that this is our inverse function by rewriting y as f inverse x equal 3x minus 3. And this will be our inverse function of x. Now looking at question B, part 2, write an expression for g inverse x. Again, convert it. When you get it in this notation, you're going to convert it into the equation notation. We're going to make this part of the equation, we're going to replace it with y, so y equals 2x minus 1. Again, following the same procedure as we did before, we're going to interchange x and y. And now we want to make y the subject of the formula, so I'm just going to flip the equation. After having flipped the equation, I want to make y the subject of the formula, so I'm going to, in this case here, get rid of the 1 and the 2. So I'm going to plus 1 on either side. Now having done that, I need to get rid of the 2, so because the 2 is connected to the y by a multiplication sign, I'm going to do the inverse of multiply, which is to divide. So I'm going to divide 2. Each term on either side is divided by 2. Right, so once we have a fraction and a fraction situation where a common denominator will express the numerator over a common denominator, in this case 2. So now we're going to indicate that this is an inverse function. So this is our inverse function. We're going to indicate that, so we're going to replace y with g inverse x. So g inverse x equals x plus 1 all over 2. And this is our answer. Looking at part B, number 3, write an expression for f of g of x. Now we were given before f of x equal x over 3 plus 1 and g of x equal 2x minus 1. F g of x means to say that we're going to take the entire function g of x and input it into the function f. So enclose the entire function g of x in brackets here, because the entire thing will be inputted in the function f. Now the function f of x equals x over 3 plus 1. Now since we are going to input the function g into the function f, we're going to replace this part of the function here. So it becomes f g of x equals x plus 3, x over 3 plus 1. Now g of x, what is g of x? G of x is the same as 2x plus 1. So now we can't, it wouldn't make sense that we have g of x here. We cannot input this and work out anything. So we have to put what g of x is equal to. So g of x is the same as 2x minus 1. So if g of x is the same as 2x minus 1, we're going to replace g of x with 2x minus 1, because they are both the same. Right, now having replaced that, now this is the input to the function here. So anywhere we see an x in the function f, we're going to replace it with 2x minus 1. So it's 2x minus 1 all over 3 plus 1. Now we could simplify this expression here. So this part of the equation, this could be simplified to 2x plus 2 2x plus 2 all over 3. So when we simplify this, we arrive at 2x plus 2 all over 3. So now we can restate our answer here. Our completed answer is f g of x equals 2x plus 2. And this completes the answer for this question here. Now how did we simplify this? We could just go to the working column, 2x minus 1 all over 3 plus 1, express the 1 as a fraction also. LCM here is 3 into 3, 1 multiplied by the bracketed content here will give us back the same. So 1 multiplied by 2x minus 1 will give us 2x minus 1. Bring down the sign here. 1 into 3 is 3, 1 3 is 3. After working out this, we get 2x plus 2 all over 3. And that's how we arrive at this final answer here. Looking at B number 4, write an expression for fg inverse x. Fg is equal to f of gx, which we had worked out previously. So the previous question gave us the answer to f of g, which is 2x plus 2 all over 3. We worked out that previously. Now, in this situation here, before we could find the inverse of anything, we need to work out the inverse. We need to work out f of x. That is the item in the brackets here. So because f of x is in the bracket, you need to work out that first and then find the inverse of the answer to this here. So you're following the BEDMAS rule, where first of all, you need to work out the bracket item, then the exponent, then division, multiplication, addition, subtraction. So first of all, work out the bracket and then apply the inverse. So you cannot say you're going to find the inverse of g and then apply it to f. Work out this, and we had already done that before in the previous question. So in the exam question, a lot of the succeeding question requires an input from a previous question, as in this case here. So we'll take the answer from the previous question and we'll work with that in this particular question here. So since f of g equal 2x plus 2 all over 3, we're going to replace, so f g inverse x, and since f of g is the same as 2x, so it's 2x plus 2 all over 3, and we're going to find the inverse of this function here. Right, so we already worked out f of g and it gives us that, and now we're going to find the inverse of this particular function. So to find the inverse of this function, we're going to first of all replace this part of the equation with y. So y equals 2x plus 2 all over 3. Now the next step is we're going to interchange x and y. Now this what I'm showing you here is a process of converting to convert a function into an inverse function. So we're going to interchange x and y. Now having interchanged x and y, the next step is to make y the subject of the formula. But it's my practice to flip the equation where I put the left hand side on the right hand side and vice versa. So 2y plus 2 all over 3 equal x. Now that I have this situation here, I want to make y the subject of the formula. Okay, we could carry across the question on the side here. So 2y plus 2 all over 3 equal x. Now to make y the subject of the formula, we need to get rid of the 3, the 2, and the 2 across here. So first of all, we get rid of the denominator, which is 3, so we multiply both sides by 3. So both sides of the equation is multiplied by 3, so now we have 2y plus 2 equal 3x. Now, having done that, we need to get rid of the 2, so we minus 2 on the side here, and we do the same on the other side. So we now have 2y equal 3x minus 2. Now that we have that there, we're going to divide out the 2 in this case here. Each term on the other side is also divided by 2. So y equal 3x minus 2 all over 2. Now when we have a fraction where there's a common denominator, we could express the numerator over a common fraction of 2, as in this case here. Now this is our inverse. So going back to the question, the inverse of this function f of g, remember it's a composite function, right? So the inverse of this composite function is 3x minus 2 all over 2. We're going to show that in our final answer now, that the inverse of a composite function g f g inverse x equals 3x minus 2 all over 2. And that's the final answer to this question here. Right, so the final part of this question, part C of the question, we want to show that f of g inverse x equal g inverse f inverse x. Right, so this is a bit complicated, so we need to go it over. Now we know that f g inverse x is 3x minus 2 over 2. So we now want to prove that g inverse f inverse x is the same as 3x minus 2 over 2, because they say that both are equal. So let's go and work out the answer now and see. So g inverse x, f inverse x, what this is telling us, this is equal to g, the function, the inverse of the function g. When we have that function, we're going to input into the function g inverse. So in the function g inverse, we're going to input into that the inverse of function f. And since the inverse of function f is 3x minus 3, we're going to take the inverse of function g, and we're going to input into that function the inverse of function f. And since the inverse of function f is 3x minus 3, we're going to replace it with 3x minus 3. So the inverse of function f can be replaced by 3x minus 3 because they are the same thing. And now the function g, the inverse of function g is x plus 1 over 2, x plus 1 all over 2. Right, so now we have our setup here, so it's important to get the setup correct. So now this is the function g, and function g is x plus 1 all over 2. Into this function, we're going to input 3x minus 3, which means to say that anywhere we see x in the function, in the inverse of function g, we're going to replace it with 3x minus 3. So 3x minus 3 plus 1 all over 2. 3x minus 3 plus 1 will give us 3x minus 2 all over 2. Now we can see that this is the same as this here, 3x minus 2 all over 2. So 3x minus 2 is the same as 3x minus 2 all over 2. So now we can conclude that, so hence f of g inverse x equals g inverse f inverse x as 3x minus 2 over 2 is equal to 3x minus 2 all over 2. And this is how we prove that the function f of g inverse, of course this is in brackets here, f of g inverse x is the same as g inverse f inverse x. And that will conclude this part of the question here. Looking at this question taken from the June 2002 past paper, we have a question on a function, so take your pen and paper and attempt the question before looking at the answer as usual. So we have the function, find the value of g2. Function g is such that x maps onto x plus 2 over x minus 5. So the first thing we need to do is write it in this notation here, as it's easier to work with when it is in this notation here. So for x is the input value. That is the input value into the function. So the input value into the function is 2. So anywhere you see at x in the function, we're going to replace it with 2. So it's 2 plus 2 all over 2 minus 5. 2 plus is 4. 2 minus 5 is negative 3. So your answer is minus 1 and a third. So it's a simple question, and it's not so difficult to do this question here. Looking at question B, for what value of x is the function g of x undefined? So undefined means to say that, so when a function is undefined, the denominator must be equal to 0. So for the denominator to be equal to 0, first of all we're going to set the denominator to 0. So for the denominator equals 0, you set the denominator equal to 0 and you solve for x. So x equal, you minus 5 on both sides. Sorry, plus 5 on both sides. So x has to be positive 5. Therefore, for the function to be, for the value of x for the function to be undefined is 5. Now we can go back to the question and see if that is actually the answer. So x plus 2 all over x. So when x is 5, we see we have 7 over 0. So when x is 5, the denominator is 0. Hence, the function is undefined. So again, to answer the question, so x must be equal to positive 5. And again, so I'll just reiterate, for a function to be undefined, the denominator has to be equal to 0. And since this x minus 5 is the denominator, we set the denominator to be equal to 0, work out or solve for x. X is equal to positive 5, so therefore x, which is equal to positive 5, means to say that when x is positive 5, the function is undefined, because positive 5 negative 5 will give you 0, and hence the function will become undefined. Looking at question C, write an expression. So you're going to write an expression for g f of x. So g f of x so g f of x equals the function f of x being inserted into the function g. So the function f of x is equal to 3 minus x. So therefore this function will be placed into the function g of x. So now that we know that the function f of x equals 3 minus x, we're going to replace f of x with 3 minus x. Right, so now that we have f inverse, we have fx as being 3 minus x equal x plus 2 over x minus 5. Anywhere we see an x in the function here, we're going to replace it by the entire bracketed content here. So the entire bracket, we're going to replace the x value with. So instead of x, we will write 3 minus x plus 2, and x again, we're going to replace x with 3 minus x minus 5. When we remove the brackets, this will become 3 minus x plus 2, right? Because all we need to do is to multiply 1 by each of the elements inside the bracket to remove the bracket. So 1 multiplied by everything here will give you back the same thing, and that's how we remove the brackets. The same thing for the denominator here, we get 3 minus x minus 5. Now we can simplify this here. So we simplify this, we get 5. So you get 5 minus x and negative 2 minus x. So this here will be your answer. Looking at question D, so looking at question D here, for the function f of x equal 3 minus the sine value of f inverse 4. So first we're going to find the inverse function. So first we're going to find the inverse function in this case here. So f of x equals 3 minus x. Again, this is a process for finding the inverse of the function. So we're gonna let f of x be y equal 3 minus x. After that, we're gonna interchange x and y. After having interchanged x and y, we want to make y the subject of the formula. So we're gonna, as to make it easy for us to work with it, we're gonna flip the equation in which we put the right hand side on the left hand side and the left hand side on the right hand side. We do this so that we have y on the left hand side, as we want to make y the subject of the formula, and the subject of the formula is usually but not always on the left hand side. So we already have it on the left hand side here. Now the next step is to get rid of the 3. So we're going to minus 3 on both sides. Minus 3 plus 3 will give us 0, so we are left with negative y equal x minus 3. Now that we have negative y equal x minus 3, divide the negative y by negative 1, and each of the item on the other side is also divided by negative 1. So a negative by a negative gives us a positive, and this will be negative x plus 3. So x divided by negative 1 will give us a negative x, and negative 3 divided by negative 1 will give us a positive 3. The reason why we divide out by negative, because the answer asks us, or the question asks us, what is the value of y? So we could not have left the y to be negative. So in order to remove the negative on the y, we divide the negative y by a negative 1, which will render the y positive. And we do each term on the other side of the equation, we need to do the same, divide by negative 1. Now that we have this here, we're going to replace the y by a f inverse x equal 3 minus x. And this is our inverse function. Now taking the inverse function, so inverse function, we're going to take the inverse function. But remember that we want the inverse function where the input value into the function is 4. So now that we have, so the first step is to work out the inverse of the function, and this is a process of working out the inverse of the function. Now that we have the inverse function, which is f inverse x equals 3 minus x, we need now to go and work out the value of the inverse function when the input value to that function is 4. So anywhere you see x in the inverse function, we're going to replace it with 4. So f inverse 4 equal -1, and this is the answer that we are looking for. F inverse 4 equals -1. All right, so looking at the following question, question number 2, is a question taken from the June 2001 past paper. So although it is a question from way back in 2001, it is still relevant even today. All right, so part A, find the value of g -5. So g inverse, the g of x equal x plus 3. Again, as we have been doing, wherever you see the -5, we're gonna replace the x with the -5 because the -5 indicates the x value. So in this case, it's -5. -5 plus 3 will give us -2. Hence, the function g -5 equal -2. Looking at part B, find the value of g inverse 7. Again, in this question, we're going to work out the inverse function first. As usual, I'm going to replace this part of the question with y. So y equal x plus 3. Now we're going to interchange x and y. After having interchanged x and y, we need to make y the subject of the formula. But as is my practice, I'm going to flip the equation where I put the left-hand side on the right-hand side and the right-hand side on the left-hand side. Okay, having done that, I need to make y the subject of the formula. So in this case, I'm going to minus 3 on both sides of the equation. So minus 3 will get rid of this 3 here, leaving y by itself. And remember what you do on one side of the equation, do to the other side of the equation. So now I have y equal x minus 3. So now that we worked out the inverse function, which is x minus 3, we're going to replace the y by the g inverse x equal x minus 3. So g inverse x equal x minus 3. And now we're going to place into the function, into the inverse function g inverse x. In place of x, we're going to place the value of 7. And wherever we see the x in the inverse function, we're going to replace the x with 7. 7 minus 3 is equal to 4. And it's a simple equation to work out, and our answer is 4. looking at C and the final question here, we asked to find the value of HG. So again, we asked to find the value of HG of G input 0. Now, in this type of question, we know that we're going to take this function and input it into the function in front. So the function G will be inputted into the function H. However, because we have a number here, remember we have a number here, so we need to first of all work out what is the value of the function G of 0. And having worked out that function, then we put it in the H function and work our answer. Now we were given the function G of x equal x plus 3, and H is such that x maps onto x squared. So we're going to change it from this notation to this notation here. So the notation is H is such that x maps onto x squared, changing to hx equal x squared, as it is easier to work with the function in this notation here. So again, first of all, you're going to work out the G of 0. So anyway, 0 plus 3 equals 3. So G of 0 equals 3. Now that is the value. So we're going to restate our original question. H G of 0 equal, and we're going to replace the G of 0. Since the G of 0 works out to be 3, we're going to replace the G of 0 with the number 3. So our function will be H3 equal, and looking at this function is x squared. Now that we have that here, we know that the input to this function Hg of 0 equals 3. So that is, it means to say that anyway, you see x in the function h, we're going to replace it with 3. So 3 squared equals 9. And that's our answer here. So recapping, when we're asked to find a and this is known again as a composite function. So it's a composite function where we have one function as input into the other function. So first of all, we need to work out the value of the function G of 0. We went there and work out the value of G of 0. We got 3 as the answer. We state the original question, which is Hg of 0, and since G of 0 is the same as 3, right? So since H of 0 is the same as 3, we're going to remove the G of 0 and replace it by 3. Or we're going to replace it with 3, because that and 3 is the same. So now 3 will become the input into the function h. And the input into the function h basically means to say wherever I see x in the function h, I'm going to replace it with 3. So 3 is replaced by 3 replaces x. We work out 3 squared will be 3 3s are 9. 3 squared equals 3 3s are 9. And this is our answer here. And that concludes the answer for question number 2.